Hi guys, Dr. Diaz here again. Okay, last class we were discussing the parabola, and well, let's do just a review, at least of the equations. You remember, this is the equation. Well, this is actually the graph of a parabola. The equation of a parabola is this one here, which is when it's a line along the y-axis. You have an x squared is equal to 4cy, and if c is bigger than c, there's concave up. And the same thing, if c is smaller than c, there's concave down. And the other ones, the ones that are lying along the y-axis, which the equation now looks like y squared is equal to 4cx. If c is bigger than c, there's a line along the positive side of the x-axis. If it is negative, it's a line along the negative side of the x-axis. An example of a parabolic mirror, which we mentioned in class, talking about orbits of planets and comets and in telescopes. Look here, in the case of telescope, we have here a parabolic mirror, which the lights, when it hit the mirror, they will converge at the focus, and they will go through all the way here through the along the optical axis, where it's usually you have the occurrence, and then you can see the celestial object. Okay, now today we're going to, right now, not today, we're going to discuss now, we scroll up, the ellipses, yes. And the definition of ellipse is, here says an ellipse is a set of point px, we have px here, and in a plane such that the sum of the distance between p and two fixed points, f1 and f2, which we call focus, is constant. The fixed points, f1 and f2, we have it here, and the the midpoint of the line of the segment join those points f1 and f2 is called the center. Yeah, you know what happened when these two these 2 points here converge, the ellipse turns into a circle, sort of. Well, the thing is, we're going to work with this one, and here we have the equation of an ellipse. I'm going to write it here in a second, and we have here the equation of an ellipse. S squared divided by a squared plus y squared divided by b squared is equal to 1. Now, this ellipse will be a line along the x-axis like this one is showing up here if a is bigger than b. If you have it this way, x squared divided by b squared plus y squared divided by a squared equal to 1, well, this one is a line along the y-axis. Now, if you see these ellipses here, it has, well, some features, which is the vertex, these 2 points here, vertex. It has a semi-minor axis, or a minor axis here, and it has these points here which are interesting, the focus, which we're going to be able to calculate not only the focus and get those vertices and draw the ellipse. Also, we should be able to calculate the eccentricity. So first, let's do some simple problems with an ellipse, and then we're going to start doing more interesting stuff. Let me scroll here a little bit. Let's do this example. Graph 4x squared plus 25y squared is equal to 100. Okay, this does not look like any of these two equations of an ellipse, a line along the x or y axis. But we have to turn this into that equation. First thing you have to notice is that the equation of ellipses always is equal to 1. The other thing is that which axis the ellipse is going to be aligned, it will depend on the denominator here. If a is much bigger than b, then this one is aligned along the x-axis. Let's say, in this case, if b was bigger than a, then this will be a line along the y-axis. So we don't know exactly this case, but the first thing we're going to do is we're going to divide everybody by 100, because we notice that the equation of an ellipse always says whatever is this is equal to 1. So we go here, 4 divided by 100, x squared plus 25 divided by 100, y squared is equal to 100 divided by 100, which is going to give us something like this. X squared divided by 25 plus y squared divided by 4 is equal to 1. Now this looks like an equation of an ellipse. Now it says here, this major axis is going to be a squared is going to be equal to 25, so a is equal to plus or minus 5. Now we're looking actually for these 2 points, because we know this one is a line along the x-axis, since 25 is bigger than 4. Then we have b squared is equal to 4, so b is equal to plus or minus 2, which is going to be these 2 points here. Now what we're going to do, We're going to draw here. Let's put a set of coordinates here and see how this looks. Now here, well, here we have, I've just tried to put this graph here. We have 1, 2, 3, 4, 5, 2, 3, 4, 5 here. So here's one semi-major axis. It's going to be when x is 5, y is 0. Then we go the other side, -1, -2, -3, -4, -5 here. More or less, you know, I'm doing this more like an I percentage, -5 and 0. Then we go here, 1 and 2. 0 and 2, and then here 1 and -2. 0 and -2, and then what we have to do is just put the points here. And here's our ellipses. Yeah, something like that. Okay, I failed that one. I didn't touch that one, but it looks like this. And it's centered at the origin here with 0, 0. Right? Yeah, perfect. This is more or less how you do graph your ellipses. Okay, you have the vertex here. Vertex. You have here the semi-minor axis. We haven't calculated the focus yet. Well, yes, we haven't calculated that one, but we're going to do that in a second. First, I'm going to show you how to graph this thing. Then later, we're going to do the whole thing, which is calculating the centricity and the focus. So let's go see more challenge examples. You know what? Let's finish this problem. Let's try to find their focus, and let's even calculate their centricity. So first thing we have to do is find the value of C. So C is defined as C squared is defined as A squared minus B squared, or let's say the semi-axis major minus the minor. And solving for C, you get C is equal to the square root of A squared minus B squared. And in this case, we have what? The square root of, it's going to be 25 minus 4, square root of 21. And you can use a calculator and get this one. So we get C is equal to 4.58. And because this one is aligned along the x-axis, is going to be then the focus is going to be C and 0 and minus C and 0, which is going to be somewhere around here. This is, well, positive 1, 2, 3, 4, 4.58. 4.58 somewhere around here. Negative 4.58 somewhere around there. There is where the focus is of these ellipses. I should have used a different color. Let me close this for a second. Stop right here. So we have the focus is going to be is 4.58. Let me stop this. 4.58. Oh, sorry. That's not true. So it's 4.58 and 0 and negative 4.58 and 0. And now the eccentricity, which just tells you how elliptical it is. The ellipses is, and now calculating this time, we get the eccentricity is defined as that focus divided by the semi-major axis. In this case, it's going to be 4.55 divided by 5. We get like 0.9165. And what it tells you about these ellipses, well, it is something like this. We know that the eccentricity is going to be between 0 and 1. It's not going to be bigger than 1. It's not going to be smaller than 0. But the closer it is to 1, the more in log and flattering is that ellipse. The closer it is to 0, the more it looks like circular. If you look at the orbits of the planets, some of the orbits of the planets are actually not that elliptical. They look like a circle. So the eccentricity is not going to be that big of a number. Okay. The next one, we're going to do a little bit more challenge problems, and I'm going to show you some of the other examples that we have here from the textbook. So wait for the next video. See you guys in a second. Bye.